Okay, mathematicians, we are back with example 3 and 4. 3 and 4 are going to be quick, so this video is going to be fairly short, which is nice. Example 3. So again, we'd already done 1 and 2, went over that. Now we're looking at example 3, so part 2 of tables. Okay, example 3. For every 7 days, Jack runs a total of 4 miles. Create a table to find out how many days it would take Jack to run 12 miles. So again, looking at two things, I have my two different colors here. We have 7 days. Looking at days, right? We have 4 miles here. Looking at 4 miles. And we have a question this time. So we don't have a task like example 2. We kind of have a question here, just like example 1. How many days it would take Jack to run 12 miles? My Q, again, my data is up here. My question, my data. How many days would it take Jack to run 12 miles? Okay, so we have 2 units of measurement here. We have days and miles. So I'm going to create my table. I'm just going to put days first, then miles. It actually doesn't matter, but I'm going to, since I was told days first, I'm going to write that there first, and then miles second. Okay, how many days was Jack? Our ratio for this amount that Jack runs, so every 7 days. Let's give me my 7 here. And then what goes with that is every 7 days, 4 miles. So 7 for every 7 days, 4 miles. Now we're trying to get to 12 miles. How many days would it take Jack to run 12 miles? So we want to know how many days. We're looking at miles when we're trying to get to 12. Here's what I like about tables. So I could skip count like I did here. I added the same thing every time, starting with my ratio. So adding 2 every time, adding 9 every time. That works. If you're ever stuck, just do that. But I'm going to start looking at this as I get better with my, my multiplication and recognizing ratios. So here, when I see that I want 12 miles, I can already get to that 12. My goal is to get to 12 miles. So I am going to not worry about skip counting 4s all the way to get to 12. I already know my times tables. I know I can get to 12 by doing some kind of multiplication here. So 4 times what equals 12 is what I'm thinking in my head. 4 times what is 12? That's times 3. And I know from what I talked about in the last video is that I have to then go to the other one that's right across, the other number, my 7 days for 4 miles, and now multiply it by the same number that I multiplied here, so timesing 3. 7 times 3 is 21. Okay, and let me just kind of write over this again. It's kind of hard to see. I know it's that orange color. So if I know 4 times 3 gave me that 12, 7 times 3 is this 21, and I don't even need to do the rest of the table. I already have the work I need. Now, if you're worried that you don't know your times tables as well, again, this will work, but look how fast that was. So learn those times tables or just start recognizing ratios and how they're related to these times tables. Okay, so here, our answer's somewhere in here. It says, again, how many days? So we're looking at our days. For this 12 miles, 21 days. And I do want that, again, in a sentence. Okay, revisiting QD Pack, we have our question, our data. Here was our plan, was making a table, because this notes is about tables, right? So we're going to be talking about tables. We found our work and our answer in this work, and we're going to say it in a sentence. How many days it would take, we're trying to find out how many days it would take Jack to run 12 miles. It would take Jack how many days? We just found it, right? 21 days. And I think I can fit the rest. To run 12 miles. To run 12 miles. Okay, good. That's it. So my table can be short and sweet, right? Example 4. What ratio is shown by the table below? Explain in words what this ratio means. Okay, so we have a table that now we've gone from taking information and making a table. Now we're taking this table and trying to interpret it. We have, again, explain what ratio is shown by the table below. Explain in words what this ratio means. So there's 2 things we have to do here. We're looking at it to figure out what's the ratio. We are then explaining in words what this ratio means. okay, using this table. With two things. We have students, so I'm going to kind of circle my colors here, students and teachers. This is my table label. So my ratio is something to do with students and teachers, right? And then I'm now trying to figure out a ratio. So there's a lot of numbers here. Any of these are a ratio, technically. So 30 students for every 1 teacher, 60 students for every 2 teachers, 90 students for every 3 teachers, and 120 students for every 4 teachers. So any of these can be the ratio. Now when we look at simplified ratios though, we're looking at the one where it is, I can't double it together anymore. I can't do anything. It's at the simplest version it can get. And that's going to be anything with a 1. Okay, so it's called a unit rate in this case. This is the 1. Or if it's not 1, say you have 2 to 3 or 4 to 5, you can't now divide anything else to try to simplify it, kind of like how you would simplify a fraction. So I'm going to go right into the simplest ratio. Again, any of these ratios, because it doesn't say simplified ratio, any of these will work. But I'm going to go right to my simplified version, which is this 30 students for every 1 teacher. So the first thing they're asking is, what is the ratio shown in this table? Again, I'm going to go simplified version. And I'm going to write the answer in here. The ratio is 30 to 1. Again, I'm kind of trying to color code it here. 30 to 1. And we're using a colon here to show our ratio. We could also use the word 2 or a fraction. We'll just go with that, with the colon. Now we want to say in words. So in words, what does this mean? Well, this is probably looking at a classroom ratio. Just when I look at teachers and students, my experience at school tells me this is probably a ratio of how many students are in each class with a certain number of teachers. So there's 30 students when there is 1 teacher in a classroom. That's what I'm assuming here. So we're just going to say for every 30 students, 30 students. And again, I'm going to kind of color code this, comma. There is 1 teacher. And I'm going to use my kind of number since I didn't want to write out the word. And a 1 kind of looks like an L. So since I'm kind of saying in the sentence, I kind of will make my 1 look like that, like kind of Times New Roman 1. Like if you think about fonts, right? So if I leave it like just a regular 1 like up here, it looks like an L. So once I start putting it with words, which we'll start doing more and more, and we'll start using variables and things, we will not use like an L and a 1 together because they look too close together, right? Okay, so for every, back to this though, for every 30 students, there's 1 teacher. Okay, so we have this all completed. We will be talking more about like when are tables more useful versus like a tape diagram or some of the other things we will learn if we have not already discussed them. But tables, again, is one of the ways we will solve ratio problems. Okay, thank you, Scotty. See you tomorrow. And have a great night.